Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.37. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across a closed loop circuit elements is always zero. We also will be using Ohm's law. According to this law, voltage across resistance R is always the product of current through that resistance and the value of resistance. Now move towards the problem. Exercise problem number 2.37. Find voltage VBD in given below figure. This is the circuit diagram of given problem. We have to find voltage between these 2 points labeled as VBD. This is a closed loop circuit. In order to find voltage VBD, first we have to find voltage across these resistances. For that purpose, we will apply Kirchoff's voltage law to solve this problem. Before applying Kirchoff's voltage law inside this circuit, first we have to assume the direction of current. We are assuming current I is flowing inside the circuit in clockwise direction. Now, according to the assumed direction of current, make polarity notations across these resistive elements. Current entering terminals are taken with positive sign and current leaving terminals are taken with negative sign according to the passive sign convention theory. Now write KVL equation for this closed loop. Start from 4 volt. Current entering terminal is positive, so 4 volt will be taken with positive sign. Move to the next element. Current entering terminal of this voltage source is negative, so voltage across this voltage source will be taken with minus sign, minus 12 volt. Move to next element. Current entering terminal is positive, so voltage across this 3 kilo ohm resistance, that is the product of current through it and the value of resistance I multiplied by 3K will be taken with positive sign. Move to the last element. Current entering terminal is positive, so voltage across this 1 kilo ohm resistance, that is the product of current I and 1 kilo ohm, will be taken with positive sign. Now solve this equation to calculate the value of current I that is flowing inside this circuit. Subtract 4 from 12, it will become minus 8 because larger value have minus sign along with it. Multiply 3 kilo with I and 1 kilo with I and add these together because both values have same variable I, so their sum will be 4 kilo I. Now place this minus 8 on the other hand side of equal to make it positive and divide on both sides with 4K to calculate the value of I, that will become 2 milliampere. We have calculated the value of current I, so we can calculate voltage across this 3 kilo ohm resistance. Here I would like to share a note. For the calculation of voltage VBD, I am selecting left half circuit. You may select right half circuit as well. In both cases, the answers will be same. Now, in order to calculate voltage across this 3 kilo ohm resistance, we will use Ohm's law. We are assuming voltage across this 3 kilo ohm resistance is V and the value of V is the product of current through this resistance and the value of resistance. Value of current is calculated in previous step, that is 2 milliampere, and this current is entering from positive terminal of this 3 kilo ohm resistance, so current will be taken with positive sign 2 milliampere multiplied by 3 kilo ohm. So the value of voltage across this 3 kilo ohm resistance will be 6 volt. Update the circuit diagram according to these calculated voltage that are appearing across this 3 kilo ohm resistance. Now we are interested to calculate voltage between these 2 points that are labeled as VBD. And this VBD is indicating that point B would be on higher potential than point D. For the calculation of VBD, apply KVL inside this semi-closed loop. First assume the direction of current. I am taking the direction of current clockwise. You may take counterclockwise as well. And write its KVL equation. Start from VBD. Current entering terminal is positive, so VBD will be taken with positive sign. Move to next element. Current entering terminal is negative, so 12 volt will be taken with minus sign. And move to last element. Current entering terminal is positive, so 6 volt will be taken with positive sign. Now subtract 6 from 12, it will become minus 6 because larger value have minus sign along with it, and place this minus 6 on the other hand side of equal to calculate the value of VBD. That will become 6 volt. So value of VBD inside this circuit is 6 volt. This was exercise problem number 2.37. Thank you. See you again in next video.